Hi guys. Today we're going to talk about section 9.6, inverses of trigonometric ratios. This is actually our last lesson for trigonometry as a whole. So we're almost done with chapter 9. We're almost going to sum it up, close it, and be done with it forever. But first, we need to talk about the inverses of trig. Now, if you remember from last class, we were talking about how to find missing side lengths with trig. So if you look at the bottom of this one-page sheet of notes, these four examples, 7, 8, 9, and 10, are just like what we did last video, where we were finding a missing side length. So we were given one angle, one side, and we needed to find that other side, so that x value for all of those. So even though it's at the bottom of the page, it might be a good idea to start here just as a refresher. So if we look at this first one, remember everything is always in terms of the angle. So I like to mark that angle. This will work. I like to mark that angle so that we know what we're looking at. And then you have to label all three of your sides. So if I'm looking and go straight across from that angle, that would be my opposite side. The hypotenuse is the side across from the right angle, so that would be this guy. And then that third side is your adjacent side. So that's always the first step. You just want to label, make sure that you have everything filled out nice. Then the next thing that we want to do is circle the information that we have. So remember, the information that you have could be a number for the side length. It could be this 11, or it could be a variable, because that's what we're looking for. So we do still have information there. So in this case, I have A and I have O. Now, if you remember our functions, I have sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So in this example, I have an O and I have an A. I don't have anything to do with that H. So it can't be sine, it can't be cosine, it has to be tangent. So then from here, I need to set this up. So it's always tangent of the angle. The angle's the number with the degree symbol, so that's the 39. So it's the tangent of 39. And then that equals 11 over the adjacent side, x. So that's my setup. I'll go through this one fully because this one is a little bit weird. So remember, x is in the denominator. So what I need to do, I need to switch the positions of these guys. So then instead, I would have x equals 11 over the tangent of 39. And then I can plug that into my calculator. So remember, using that Google calculator, you need to have it in degree mode, right? So I can just do 11 divided by the tangent of 39. And I get 13.58, which rounds up to 13.6. So that's that missing side length there. All right, so that's that first piece of review. The second one I'll label and I'll start the setup. I'll give you the answer, but you'll have to do the rest. So we're looking at 46 degrees. That's the angle in question. If I go straight across from that, that gives me my opposite side. If I look across from the right angle, this would be my hypotenuse. And then that third side is my adjacent side. Circling what we are given, we're given the adjacent side and we're given the hypotenuse. So that means we're using cosine. And then I want you to set it up. But your final answer, to make sure that you're doing this correct, should be x equals 19.5. All right. So you can pause this here, try that example, make sure that you got it right. And then looking at 9. So I'll do the same thing for 9. So we're looking at 51. If I go straight across from that, this is my opposite side. If I go straight across from the right angle, this is my hypotenuse. And then the adjacent side is the side next to that angle. So circling what I have an A and an O. So that leaves me with tangent. Again, I want you to set this up, solve, but to make sure that your answer is correct, you should have x equals 6.5 when you're all done. And then finally, looking at this last review example, same thing, I want to label. I'm going across, that's my opposite. If I go across from the right angle, that's my hypotenuse. And then the side next to it, the adjacent side. Labeling what I have the hypotenuse and I have the opposite side. So this one would be sine. Again, you set it up and solve. When you solve, you should have 12.6. So I want you to try these three. It's not getting a grade or anything, but it will definitely help you in the long run when it comes to doing the problems above and then working on today's lessons activities for the next 2 classes. So it's very, very important to know how to label the sides. Like, is it the opposite side? Is it the adjacent? Is it the hypotenuse? So this was section 9.5. This was finding sides. Then if we come back up to today's lesson, this is a little bit different. So now if you just look at the examples that are given, instead of having the angle measures, we're looking for the angle measures, right? So if you look at the bottom examples, x was a side length. We were looking for that side. If you look at these top examples, we're not looking for a side anymore. We have 2 of the sides. What we're looking for is that angle. Now, in order to do this, we have to use the inverse trig ratios. So basically, following this little blurb, it says if you know the sine, cosine, or tangent of any angle, you can use the inverse of the ratio to find the measure of the angle. So this is all calculator work. It is pretty similar to what we were doing last time, but there's no multiplication or division involved like last time. Now, you might be a little bit confused on what an inverse is. So really quick, just to give you an explanation, inverses are things that undo each other. So if you look at addition, the operation that undoes addition is subtraction. If you look at multiplication, the operation that undoes multiplication is division. Even if you had like x squared, the operation that undoes a squared is square root. And then if we look at sine, the operation that undoes sine is sine to the -1. And it's just a button on your calculator. So even these Google calculators have the inverse. So what you would have to do is you'd have to press INV, and then notice how sine to the -1, cosine to the -1, and tangent to the -1 all pop up. So if you haven't been using this Google calculator, I would recommend using it just because it makes it easier. You have to make sure it's in degree mode, and then you'd have to press inverse, and those guys will pop up. So let's go through a few examples. Let's see how this goes. So looking at the first one. Now my initial steps are all the same. Everything is always in terms of the angle. So I just want to mark where the angle is. It's here, and then label all my sides. So if I go straight across from that angle, that's my opposite side. If I go straight across from the right angle, that's my hypotenuse. And then that third side, the side next to the x, that's my adjacent side. So again, first step is still the same. Now I'm asking myself, out of the SOHCAHTOA acronym, which one can I work with here? Which one do I have enough information for? So if we kind of circle everything that we're given the same way that we usually do, I have the hypotenuse, there's something there, and I have the opposite, there's something there. The adjacent side, I don't have anything. I have no number. It's useless to me. I can't use it. So since I have the opposite and the hypotenuse, that is OH. So I would be using sine. Now it's always sine of the angle. So here my angle is x. And then that equals the opposite, which is 15 over the hypotenuse, which is 24. Now, don't freak out. Don't touch these fractions yet. Think back to solving a standard multi-step equation, right? We want to get x by itself. So usually what I would have is, just as a complete irrelevant side note, I would have like 2x equals 10. This is 2 times x. In order to get x by itself, I would have to divide by 2 because that's the inverse of multiplication, division. Now, if I do it on the left, I also have to do it on the right. On the left, they're inverses, so they undo each other. It's gone. And I'm left with x equals 10 divided by 2, which is 5. You are going to follow the exact same steps here. It's just that instead of having an inverse be multiplication or division, the inverse of sine is sine to the negative 1. So I'm going to show every step. So I would do sine to the negative 1 of the entire left side, and then that would cancel. And I'd be left with just x. But what I do to the left side, I also have to do to the right side. And I clearly didn't leave enough room. So I'm also going to do sine to the negative 1 of the right side. So then I have x equals sine to the negative 1 of 15 over 24. All right, now I have x by itself. The only thing I have to do, I have to plug this in the calculator. I need to get a number. Can't leave it like this. I need a number. I need to know how many degrees that is approximately. So I'm going to go back to my calculator. It's in degree mode, so I'm good. I press the inverse button. I can see the inverse of sine, cosine, and tangent. I'm working with sine, so I'm going to press sine. Comes up arc sine. That's fine. That's just another way to say the inverse. And then I'm going to plug in 15 divided by 24. Close my parentheses. Press enter, and I get 38.68. Now, I want to round to the nearest tenth, so that would be 38.7, and that's degrees. That's my answer. So it might seem a little bit weird, but let's try the next problem. Let's keep going, see how it works out. So looking at the second problem, right? So same steps always, starts out the same as 9.5. I want to label all my sides. So I go across, that's my opposite. If I go across from the 90-degree angle, that's my hypotenuse. And then the side next to is my adjacent. Nothing changed. So that's why this labeling is very important, making sure that you understand which side is opposite, which side is adjacent, and which side is hypotenuse. Then from here, we want to circle the information that we have. So looking at this, I have the hypotenuse, it's 11, and I have the adjacent, it's 8. There is no information for the opposite side. I don't have a variable, I don't have a number, I have nothing. So that is irrelevant, I cannot use that. Scribble it out, it's not useful here. Now I have A and H. This is OH. Here we have AH, and then this is OA. So that's C, so that means I'm using cosine. Now it's always cosine of the angle. Here my angle is X. And then that equals the adjacent side, which is 8, over the hypotenuse, which is 11. I need to get the x by itself. Again, I'm using the inverse function here. So if I say that I have the cosine of x, in order to undo that cosine, I need to use the inverse cosine. So I am going to skip the step of writing it all out. I feel like that might make it a little bit easier. So here that would cancel. I'd be left with just x equals, and then I would have the inverse cosine of 8 over 11. I have the x by itself. That's my goal. My last step, I just need to plug it in the calculator. So clearing out what we have. Notice how, please don't make this mistake, every single time you have to press the inverse button. Right now it just says sine, cosine, and tangent. You have to press inverse in order to see those inverse functions every single time. So here we're dealing with cosine, and then it was 8 divided by 11, closing my parentheses, and I get 43.34. That does not round up, so that stays as x equals 43.3 degrees. All right, This is literally the entire lesson. I'm going to do one more example with you guys, and then I want you to try 3 on your own. It will be similar to in class. I'll give you the answers. I just want to make sure that you know how to get to the answer. So let's look at 3. 3, same steps. Label your sides. So I'm looking at the angle. Always, always, always in terms of the angle. I go across. That's my opposite side. If I go across from the right angle, that's my hypotenuse. And then the side next to is my adjacent side. It's all labeled. I'm good to go. It's probably one of the most important steps, even though it seems like a small step, because that ensures that you're using the right trigonometric ratio. So I have the opposite and the adjacent. The hypotenuse isn't giving me anything. There's nothing there. So I'm just scribbling that out. That's gone. I have O and A. If I look at SO, that's OH. That doesn't work. Ka, that's AH. That doesn't work. Here I have TOA. OA. That's what I need. So I'm using T, which is tangent. So it's always tangent of the angle. For 9.6, the angle will always be X because that's what we're solving for. We're finding the angle measure, so it will always be X. And then the opposite side is 20. The adjacent side is 37. That's my setup. If this was a test, you would get partial credit for just showing that setup. Then I have to take it a step further. I need to cancel the tangent. Well, the inverse of tangent is tan to the negative 1 right here. So that's what I'm using. So if I apply that to the left side, it's going to cancel, and I'm left with just X equals, on the right side, I have tan to the negative 1 of 20 over 37. Again, I'm almost done. Now I just need to plug this into the calculator and get an actual number for that angle measure. So going back to the calculator, clearing it out, notice it changes back. I have to press inverse. Now I'm pressing tan, and then it's 20 divided by 37. Close parentheses, enter. It's 28.39. That rounds up to 28.4. So X equals 28.4. We're talking about an angle measure, so it's always degrees. All right. So I want you to try 4, 5, and 6 on your own. Before you start that, just a couple key things to keep in mind. Some very, very common mistakes that might be made. The first one would be in your labeling. So just make sure that the opposite, the adjacent, and the hypotenuse are exactly where you want them to be. Remember, the hypotenuse is always, always, always across from the right angle. You can always start there. The opposite is across from the angle that you're looking at, and then the adjacent is the third side. That's one key mistake that people will make. They'll pick the wrong ratio by accident because their labeling is all screwed up. And you would get partial credit for that on a test. The second mistake that people may make is tangent is equal to the opposite over adjacent, right? Well, maybe accidentally you might do adjacent over opposite. So for this example 3, I might put 37 over 20. That's going to give me a different answer than if I had 20 over 37. So that's another little tiny place where you could make an error. So it's all really based on your labeling, so just be careful with that. But again, all of this will be worth partial credit. The more work you show, the better, because then you can get more partial credit. So this lesson is almost done. Now I want you guys to practice it on your own. So I want you to try 4, 5, and 6 on your own. I am going to give you the answers. So for 4, when you're finished with it all, you should have X equals 38.5 degrees. It's very sloppy. For 5, when you're finished with it all, you should have, X equals, looks like Smart Notebook froze. That's fun. Okay, 4, 5, I'm not going to write it down because Smart Notebook decided to freeze, and I'm almost done with this video, so that's cool. 4, 5, you should have X equals 77.3 degrees. And then for 6, you should have 54.5 degrees. So just giving you that one more time. 4 is 38.5 degrees, 5 is 77.3 degrees, and 6 is 54.5 degrees. Try those 3 on your own. If you get an answer other than that, please, please, please email me, chat me, make a little private comment on the assignment itself. Do something so that we can talk about it and see what happened, because then it'll make your practice more successful and a little bit easier for you. All right, so try those and then go back to Google Classroom and you'll see the next part of this assignment that's attached. And then this assignment will go along with the second one for this week. Right? Please, 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 please reach out if you have any questions. Thank you guys.